Welcome to How to Become a Production SQL Database Administrator. My name is Raphael. In this video, we're going to be talking about the concept of shrinking a database and whether you should shrink a database or whether you should not shrink a database. There's a lot of confusion in the SQL environment as to which route to take. And as you'll note, and as I'll illustrate to you, most DBAs in the environment frown upon shrinking a database because it causes massive fragmentation. And it is best practice not to do that. If proper sizing is done, which we've already spoken about, then this should not necessarily be a case. And if you do need to shrink a database, then it should certainly be a rare occasion. So I'm going to illustrate that to you now. So let's get into the academics of what shrinking a database is and why you're trying to do this. So the primary purpose of shrinking a database or the individual files, the MDF files or the log files, is to reclaim space after removing the unused pages when a file is no longer needed, and this has caused the actual file to grow. So as I said, shrinking the file may be necessary, but as we'll demonstrate, this process is highly discouraged and extremely poor practice because it causes massive fragmentation in a database. And so let's continue. So imagine you have a initial data file of 100 megabytes, and over the course of time, there's a lot of activity going on and inaction going on, and it grows to 1,000 megabytes. Now, obviously, this MDF file has grown, and now let's say you've deleted a lot of tables with hundreds of megabytes, and now you only have, let's say, 200 megabytes of space left that's used, and then the 800 is unused. So you're trying to reclaim that 800 used by shrinking the entire database to make it back to, let's say, 100. And as I said, I'm going to illustrate to you why this process is even more detrimental than the benefits. So before we begin, let's talk about a few things to note. As I mentioned, both the data and the transaction log can be shrunk individually or collectively, and I'll show you the commands under that. When using, which is the DBCC shrink database statement, this is how you shrink a database using T-SQL. You cannot shrink a whole database smaller than its original size. So obviously, if the original size was 100 megabytes and you're trying to shrink it to 90 megabytes, obviously you cannot do that. However, note that you can shrink the individual data files to a smaller size than the initial size with this command, which allows you to shrink the individual command, which is dbcc shrink file, and we'll demonstrate that in a second. The size of the virtual log files within the log determines the possible reduction in size. We've also talked about that. And remember, now the principal reason we discourage shrinking a database because it causes massive fragmentation, and that just results in the data files growing again the next time data is added. And when that happens, the entire system can slow down and cause a tremendous amount of performance issues. Because now when you're expanding the files to accommodate that new data, the SQL is holding on to that file until it grows, and you can have performance issues. So I'm going to illustrate that to you. There is an option, the automatic database shrink file. By default, it is being set to off. I would just leave as it is and do not turn this on. So that's all I want to illustrate to that. These are the two commands if you want to shrink a database. DBCC shrink database, followed by the database name and how much database you want to retain, space you want to retain, and then the individual file using DBCC shrink file. And we'll be talking about that. So what are the best practices to avoid shrinking a database? And they are as follows, which I've demonstrated to you previously. And that is size the database accordingly so as to prevent shrinking and expanding the database. We want to prevent this. We don't want to constantly shrink the database, then expand the database, and shrink the database and expand the base. If we size it properly, we should not really be shrinking a database. When the unused space is created due to dropping of the tables, and this is what we're talking about, shrinking of the database may be needed, but again, it's a very rare process if it's properly planned. Don't constantly shrink the database as it will grow. Now, I've seen in environments where they have actual jobs running on a daily basis on a massive environment. I'm not sure why or who's managing that, but they have actual jobs shrinking the database nightly on a nightly basis. And then they're talking about performance issues. And this is certainly one of the factors. And when you shrink a database, the indexes on the table are not preserved. This is the key thing. This is why it's causing massive fragmentation. And we'll be talking about indexes in the next course, which is a very important concept. The indexes on the tables are not preserved, and as such will cause massive fragmentation and have to be rebuilt. And when you rebuild indexes, which can be an extensive process, then obviously the transactional log file is going to grow again because it's a recorded event. So shrinking the log file may be necessary if your log has gone out of control. However, again, this should be also a rare occasion. So now we're referencing the log file. Regular maintenance plans should never have shrink database jobs. Obviously, as I just mentioned, there are production environments where people don't know about this, and they're having a regular maintenance plan that allows you to shrink a database wholly, and that's an extremely no-no process. So if you see that, then obviously consult with your IT professionals and figure out why they're doing that and discouraging from doing that, and I'll show you that in a second. The other factors, obviously, when you cause shrinking is, a lot of I/O is going on, input, output, a lot of CPU usage. And remember, the transaction log gets larger as everything is fully logged, even the rebuilding of the indexing. So now I'm going to go and show you the illustrate that shrinking a database causes the following. So let me just jump onto my SQL and show you this. So the following example will illustrate that shrinking a database will cause pages. Now this is what's happening there. When you shrink a database, you're rearranging the pages, which is a fundamental unit of database, if you will, from the front to the end, and it's reshuffling it in no particular order. And as a result, because there's no order, the indexing is being fragmented. And this is what causes fragmentation. It will not reduce the size of the data file. Actually, it'll increase it, and I'll show you that also. And it'll cause unnecessary I/O hits. As I said, this shrinking the database is futile because poor planning regarding sizing. So I've already talked about sizing and how you should do that. So if you properly do that, you should not be doing this particular exercise. And it should be done rarely, if ever. So now let's continue to demonstrate that. So here, if you'll notice here, I don't have a database called shrink database. So the first thing I'm going to do is just create an empty database. So highlight and execute. And let's look at the database. And there is. And if you look at the tables, I don't have any tables either. So now what I'm going to do now is I'm just going to create an initial table called initial. And there it is. And if you highlight it. And now I'm going to insert data into that table using the insert statement. And I'm just going to insert 1,500 records. Now just confirm that. And as you can see, there's 1,500 rows. And now what I'm going to do actually is look at the size of the database. So SP underscore help database followed by the database name. So if I execute this, you'll notice that the database size is 14.83. That's fine. So we've created a database, created a table, inserted data, and we get this size. So now I'm going to create another table. And on the second table now, I'm going to create a clustered index. Now, I'm going to be talking extensively about what clustered indexes are, or indexes as a whole, in the next course, part 2. But for right now, it's just a means of retrieving data fast. So let me just leave that. So I'm going to create a clustered index on that second table. And now on that second table, I'm going to create, or I actually insert 1,500 records also. And now I'm just going to do a select statement on that second table. And as you can see, I've got 1,500. So as of this point, just to look at it, as of this point, we've created a database, added 2 tables, and on one table, added 2 tables, inserted 15 records on each, and on one table created a clustered index, which is the second table. And now I'm going to look at the size of the database after doing that process. And you'll notice that the database has expanded due to the insert of the second table. So initially it was 14, I believe, 1483. And then obviously adding the second table, adding a clustered index, enlarged the database, which is fine. So now one thing I'm going to do is I'm going to check the fragmentation of this second table. What that means is, simply put, and don't worry about this script, I'll provide this for you. Simply put, it means how is the cluster index sorted? Is it sorted well or not? A high fragmentation index in percent indicates that this data is not sorted. Here, as you can see, it is sorted because there's no fragmentation. So don't worry about this process about fragmentation. The concept I'm trying to illustrate to you here is that when you shrink a database, this either increases or decreases. So let me continue. Notice that the fragmentation of the clustered index on the second table is almost zero, as I said, before the shrink. So we will now drop the initial table we created and execute shrink command to reclaim the space from the front table. See what happens to the fragmentation. So this is the whole purpose of what we're trying to illustrate. And that is that when we have a database that is growing and growing and growing, and then at one point we delete various tables that are very large, and we've got now unused space. We're trying to reclaim that space and give it back to the database or to the server, to the operating system. And so let's see. So the initial table with 1500, I'm going to drop it, and I'm going to see if anything happened to the database. So now I'm going to look at the size of the database after dropping the initial thing, and you'll see that the data file has not shrunk due to the deletion of the initial file. So even if you're deleting the files, this is not necessarily shrinking the database. So now what you do, you come and you shrink the database. Now you're saying, hey, I've dropped so many tables, I've got this empty space, and I'm going to shrink the database to reclaim the space. And you use this command, dbcc shrink database followed by the database. So I'm going to shrink the database to reclaim that space from the initial table that I dropped. And there we go. So notice that the space after the shrink went from 23 to 15. So let's look at that database, just verify that. Or somewhere around there, but you'll notice that it did shrink. So we did shrink the database, and that's great. But notice what happened to the fragmentation of the data files because shrinking of the database. When checking the index fragmentation again, we notice that the fragmentation has drastically increased to 100% almost. This is because we have shuffled all the data pages and the index is not in a sorted order. So let's look at that average percentage. And remember, it was virtually zero. It was 0.04. And now you see the fragmentation of the index is 96%, meaning all that index is not in an orderly fashion. And now when you try to retrieve data, you're going to have massive performance issues. So while the database has shrunk and we have reclaimed the space from the data file, now we must now fix the fragment problem. Whoops. We must fix the fragment problem of the index by rebuilding the index. So we have to do that. And this is how you rebuild a index or a cluster index. Alter, index, index on the column on the second table with a rebuild command. Again, I'll be illustrating indexes before, but right now all I'm doing is that index that I had that was sorted, I have to rebuild because it's fragmented. It's not in a sorted manner. So this allows you to sort it. So now I had to rebuild the thing to increase the performance. Now if I look at this again, the command, it is being fragmented, and that's wonderful, or has been fragmented or defragged. So but now if I look at my database, you'll notice that it's increased in size. Why is it increased in size? The database file has grown because rebuilding the index is a logging event. And the transactional log files is going to grow again, and this is going to be a cumbersome. We're going to be going in circles and circles and circles, and this is going to cause a tremendous amount of performance issues. Now, this is just on a silly one demonstration table. Imagine if you have 100, 200, 500 terabyte of data, and you're shrinking databases. It's going to take you hours, if not days, at times, to manage the databases. So this is why it's highly discouraged to shrink a database. So the best practice of shrinking database is A, not to shrink a database. B, size your database and log files appropriately which I've demonstrated to you earlier. So if you do that, you will not need to do this. And if in a rare case you have to do this, then it's fine. But this will certainly demonstrate to you that shrinking a database causes massive fragmentation, and we're going to be going in circles. So it's highly discouraged. So again, I highly recommend you take a note of this, pay attention to this concept, read a little more about it, and understand that why many DBAs in the DB environment discourage you from doing that. And there are always times, as I said, there's exceptions, and that's fine. There are always exceptions. But generally, we do not do that. So I hope this illustrated to you that shrinking a database is not the norm, and they should be highly discouraged. So I'll leave it there, and we'll continue with the next video. So my name is Raphael, and this is how to become a production SQL database administrator.